And everybody, we're going to be graphing a couple more parabolas in this video. But in this sense, we're going to be graphing parabolas in standard form in which we have vertices that are not at the origin. So a little bit more not white bread without the crust, and a little bit more fun, and maybe a little bit of manipulation going on. But yeah, let's go ahead and get started. Okay. Recalling that the standard form of the equation of a parabola, if it opens up as this quantity x minus h squared equal to 4p times y minus k, which is a linear quantity. And if it opens left to right, we say it's actually y minus k, this quantity squared. And that's equal to 4p times a linear quantity. In this case, it'd be x minus h. But keeping in mind, whether it opens up or down or sideways, that k is always hanging out with y and h is always hanging out with x. And 4p, p really is the directed distance from the vertex out to the focus of the parabola. So let's go ahead and get started. The three things we want to find here, and we're always going to kind of do it in this order, but we want to find the vertex, okay? First, we want to find the vertex. Second, we're going to find P, and that is it's going to lead us to the focus is really what it's going to do, and actually tell us about the orientation of the curve. But we're also going to find we're going to find the directrix, which is going to be the last thing that we typically always find. It doesn't have to be, but you know, usually works out that way. So this being said, let's go ahead and start by finding the vertex of this first one here. Now you might be saying, oh, this is great, check this out. H is usually hanging out with our x, and K is hanging out with y, and here's our P value here, and this is, everything's just great. But what I want you to notice is this. If we're looking back over to here, I can tell you a few things about this, starting with, hey, this must either open up or down, given the fact that our x quantity is what is being squared, okay? But the fact of the matter is this. We would like the squared quantity stationed on the left of the equation and our linear quantity stationed on the right. So that being said, you might have noticed over here that I've actually got both quantities on the left-hand side, and we need to have it over on the right. Now, I do want to mention this. This does not change the fact that our vertex on this, our h value, is actually positive 1, and our k value is going to be negative 2. So the splendid thing about this is we still have this quantity. But what we do want to do is we want to kick this term right here. We want to kick this loose term over to the other side, which would necessarily mean we're going to subtract it from this side since 8 was positive and it's a coefficient. So if we were to subtract this now to the other side, what we're going to find now is this new equation. We say x minus 1 squared is equal to 8 times the quantity y plus 2. Now that this is said, we've already got the vertex here as 1 comma negative 2, as we said before. But let's go ahead and do this. Let's solve for P. Now keep in mind that this coefficient here is actually 4P in our standard form, so we need to actually solve, for P. So we know that 8 is equal to 4P, or that 4P is equal to 8. So now solving for P, we say we'll divide both sides by 4, and we can deduce that P is actually equal to 2, which I will point out is positive. And this does no more than say that since this is a parabola that either opened up or down, that the focus must lie 2 units above our vertex, which would necessarily imply that this thing opens up. So now that we have P and the orientation of the curve, let's go ahead and start sketching this in. So we say we've got the y-axis and the x-axis here. We say, okay, so y, x, and let's start with our vertex, which we had stationed at, if you remember, 1 comma negative 2. I'm going to try and spread things out here. 1, down 2. Maybe I spread them out too much, but we say, okay, so here's the vertex of our curve. We say, okay, this is 1 comma negative 2 is our vertex. So the next thing we deduced was the fact that that the focus lied 2 units above, or lay 2 units above the vertex here. So on this major axis here, we're going to go up 2 units, 1, 2. We can say our focus now lies at 1 comma 0. So 1 comma 0. And then we say, okay, so 2 units below this, you're going to have to use the power of imagination here, if you can see down here. But we have our directrix, which is a horizontal directrix here. But in this case, since it is a horizontal line, we'll call this line y equals, and in this instance, negative 4. But we know this because the vertex, of course, is the midpoint between our focus and the directrix. Now, this being said, we can go ahead and kind of sketch in our parabola here, which we know opens up. But this is a lot of good information here. Okay, groovy. So let's go ahead and go over here and take a look at this. Now you're going to notice that I was kind of nice on this one. I put our squared quantity on the left, and I put our linear quantity on the right, and And 4p, huh? I suppose I didn't necessarily want to say 4p. How about we just go ahead and go with, I don't know. How about, it's kind of interesting. I've got infinitely many numbers to choose from, and I can't think of one to invent off the top of my head. So let's just go with, I don't know, 3/2. That'll be fun. We'll go with the fraction. So now that we've got this here, let's go ahead and start talking about some things, starting with the vertex. The vertex now, we say, now the elusive part of this is that the vertex is at hk. And recall that h is always kind of hanging out with our x value. So since this says x minus 5, our h value is actually positive 5, and this is y minus k here. But k is actually a positive 3. So now we've got our vertex. Let's go ahead and solve for p. Now we know that 4p is equal to 3/2. So off to the side here, we'll do a little solving for this. But we say 4p is equal to 3/2. So solving for p, we'll divide both sides by 4, or we could say we'll multiply by 1/4, but we actually end up with a p-value of 3/8. So we say p is 3/8, but you'll notice here this is positive. So since the y quantity was being squared here, we know that this is something that opens left or right, and since p is positive, we know that the focus must lie to the right of our vertex, which makes sense. We say this opens to the right as opposed to the left. So now that we've got these two things, I'm going to be a little bit more careful when I sketch this time, our x and y axes. But we know this opens to the right, which means we're going to have a vertical directrix. Let's go ahead and start by drawing in our vertex here. So we say 1, 2, 3, 4, 5. 1, 2, 3. Okay, so 5, 3 is our vertex. We know that our focus is 3/8 of the way to the right of this. So here's our focus here. And you're going to kind of have to use the power of imagination again here, but we say 3/8 units to the left of this is our directrix. So we've got a little induction to do here, or deducing, but we say, look, if this is the point 5, 3 was our vertex, we say this is 3/8 units to the right. So this is 5 3/8, or if we convert this all the way to 8, which is, I kind of have a preference to do, but we say 5 and 8 is 48 plus 3 more 8, so we've got 43/8. Now this is entirely unnecessary for some people, but we say 3. 48, 3/8, 3. And then we have this line here which is vertical, so we say x equals. But this is 3/8 units to the left of 5, so we said 48 minus 3 of those 8s would bring us down to the line x equals 37/8. And so now we can go ahead and proceed to kind of sketch this in here. But this would be our parabola. So pretty awesome.